Okay, so let's dive into a story about a new AI model that's, well, punching way, way above its weight class. It's a story that really makes you question a core belief in the whole race for artificial intelligence. See, for years now, the world of AI has basically been an arms race. The philosophy was simple. If you want smarter AI, you've got to build bigger models. Just go bigger, scale it up, throw more data at it, and boom, you get more intelligence. But this whole bigger is better approach created a huge problem, a real dilemma for pretty much everyone. On one side, you have these massive frontier models. Yeah, they're incredibly powerful, but they are so expensive and so difficult to run that they're just not practical for most people. And on the other side, you've got these smaller, lightweight models. They're efficient, sure, but they've always been seen as, well, not quite as smart. So you had to choose raw power or practical efficiency. You couldn't really have both. So in this explainer, we're going to break down how a new model is completely flipping that script. We'll look at the size dilemma, introduce this new challenger, uncover its secret sauce, check out its absolutely stunning results, and then talk about why going smaller might just be the smarter way forward for AI. All right, so let's start with part one, the AI size dilemma. Let's really get into why the industry got stuck in this bigger is better loop that a company called StepFun decided to challenge. And that brings us to section 2, our new challenger. So let's meet the hero of our story, a brand new, completely open source model called STEP3-VL-10B. And it's designed to do one thing, completely redefine that trade-off. This was built by the multimodal intelligence team at StepFun, and they had a very clear, very ambitious goal from the get-go. Their mission, really, was to prove that a small, efficient model could actually deliver the same kind of smarts, the same multimodal intelligence as its giant competitors. They wanted to prove you could have your cake and eat it too. Power and efficiency. And when we say compact, we really mean it. This model has just 10 billion parameters. You can think of parameters as the little knobs and dials an AI uses to think. Now, for perspective, the industry titans can have over 200 billion of these. So, yeah, 10 billion is tiny in comparison. Which leads us to the most important part. Section 3, the secret sauce. So how did they do it, right? How do you get giant-level performance out of a lightweight model? Well, it all comes down to a much smarter training plan, one that focuses on quality over just raw size. First, they decided to build an incredibly strong foundation. Instead of just grabbing pre-trained parts off a shelf and kind of sticking them together, they built the entire thing from scratch, all in one go. And they trained it on this massive but very high-quality data set of 1.2 trillion multimodal tokens. A token is just a piece of data, and multimodal is key here. It means it wasn't just text. It was a rich mix of words and images, learning from both at the same time. And this wasn't just a random pile of data. It was a carefully curated learning diet. It had everything: general web knowledge, academic materials from kindergarten all the way to university, data to help it read text and images, and even data to help it understand how to count things or navigate an app's user interface. This quality-first approach gave it a much, much stronger starting point. Then, after building that strong foundation, it was time to unlock its true genius. They used something called reinforcement learning. You can think of this as the AI's higher education, where it learns how to reason and solve complex problems through a massive process of trial and error. Now, a really cool part of this was a special technique they developed called parallel coordinated reasoning, or PACOR. Here's how it works. Instead of thinking in a straight line, one step after another, PACOR lets the model basically brainstorm. It comes up with multiple different ideas and potential solutions all at the same time, in parallel. Then, it looks at all those different lines of thought together, checks them against each other, and pulls them all into one final, much stronger answer. It's like having a little committee of experts in its head, all tackling the same problem from different angles. Okay, so that brings us to section 4, punching above its weight. Did this unique, quality-first training actually work? Well, the results are, to put it mildly, staggering. And they have huge implications for both businesses and researchers. This is the moment of truth. Could this little 10 billion parameter model really go head-to-head with the industry's biggest players, these giants that are 10, even 20 times its size? And boom, here's your answer. On this benchmark that tests really complex reasoning across text and images, STEP3-VL doesn't just compete with a model 20 times its size, it actually beats it. And look how close it gets to Gemini 2.5 Pro, one of the top proprietary models out there. This is absolutely wild. But it gets even crazier when you look at specialized skills. On the Amy Math benchmark, which is known for having incredibly difficult problems, it scored a 94.4%. It didn't just compete with the giants here, it blew them out of the water.
So finally, let's talk about why smaller might just be smarter. What does all of this actually mean for the future of AI, for businesses trying to use it, and for the entire research community?
You know, the biggest takeaway here is this powerful piece of evidence that intelligence isn't just about size. Smarter design, better data, and more advanced training can be just as important, maybe even more so, than just making the model bigger.
And the implications of that are huge. For businesses, this is a game changer. It means that frontier-level AI is suddenly way more accessible and affordable. You can run powerful applications on hardware that doesn't cost a fortune, opening the door for all sorts of new products and services. And for the research world, because this model is open source, it gives everyone a brand new, incredibly powerful, and efficient starting point to build on. It could seriously speed up innovation for everybody.
Which leaves us with this final thought. This really isn't just about one cool new model. It points to a whole new direction for AI development. If we can get this level of intelligence from such a small package, it makes you wonder, what new frontiers can we unlock when we realize that smarter, not just bigger, is the future of AI?